Hey guys, welcome back to Becky's World of Math. Today I'll be explaining to you how to solve a system algebraically and graphically. What the question means by solve is to find the intersecting points for the two functions. The system we have today is, as you can see on the screen, x minus 2 squared plus 4 equals 2x plus 3. So, before doing anything, we must identify what types of functions these are and in what form they are in, or the equations are in. So the first part is x minus 2 squared plus 4, and it is a quadratic function. You can tell by the square. It is in vertex form, which is a multiplied by x minus h squared plus k. The a, h, and k are all color coordinated. The second part is the 2x plus 3, which is a linear function, and it is in y equals mx plus b form. Now we go to the solving part. First, we will solve for the system algebraically. So here's a system we're working with, and we can see that the beginning is simplified. So let's just expand it so that we can see what exactly we're working with. Now that we've expanded it, let's work on this part first. So x times x is x squared. Negative 2 times x is negative 2, and that's the same thing as the next step. And negative 2 times negative 2 is positive 4. And then we just bring everything else down. We then start to combine like terms. So 4, 4, and 3 are like terms. We add the two 4s and have 8, and subtract 3 by both sides. Now we have x squared minus 2x plus 5 equals 2x. The next set of like terms are negative 2x, and 2x. We add the two negative 2x's together to get negative 4x. We then subtract both sides by negative 2x to get x squared minus 6x plus 5 equals 0. Now we're going to try and factor this. It factors into x minus 5 and x minus 1 equals 0. Now we set these two to 0 and 0 one at a time. X minus 5 equals 0. Add 5 to both sides, and x equals 5. X minus 1 equals 0. Add 1 to both sides, and x equals 1. We now know that x equals 5 and 1. Are we done yet? No! We need to find the y's for these x's. So then, we plug the x values we found into either the quadratic function or the linear function, and I chose to plug it into the linear equation because it was faster and simpler. So y equals 2x plus 3, which you replace with a 5. So y equals 2 times 5 plus 3. Y equals 2 times 5 becomes 10, so y equals 10 plus 3. And then you add those two together, and then that becomes y equals 13. And so you found one point of intersection, which is 5, 13. Now doing this to the other x that we found, y equals 2 times 1 plus 3. Y equals 2 plus 3. Add those two together, y equals 5. And now we found the other one. So the other intersection is 1 and 5. So, yay, we're done solving it algebraically. Now we need to solve it graphically. We know that the functions are quadratic and linear. I first wrote out the equation and made a table. I know that the quadratic function's vertex is 2 and 4 because of the h and k. I think of the h as x and the k as y, but looking at vertex form, what is A? A is the factor that tells you how compressed or stretched the graph will be. Something you should know about h is that when you want to graph it, it is the opposite of what it is the rule. So -2 is actually the opposite when it is graphed, which is 2. So from 0, I go right 2 and up 4. Now, using the table that was previously created, I plug in values into the x column and solve for y to calculate the plots. As you can see here, I already did that and plotted the points I found. You can already see that there are the 2 points that we found when we solved the problem algebraically. When graphing the linear equation, the equation is already in the form where we can graph it. The b, which is 3, is the starting point. It is basically saying that the starting point is 0, 3. The mx, which is 2x, is the slope. The slope is 2 over 1. Slope is rise over run. So, from the starting point, go up 2 and to the right 1. These two functions will intersect with 1, 5 and 5, 13. Now we've solved the system algebraically and graphically. Yay! Solving systems can be seen everywhere in the real world, like on freeways and train tracks, or even when you're shooting an arrow through an apple that is being tossed. The path of the apple is like a negative quadratic function, and the path of the arrow is like a linear function. If you were to draw it out, there are 2 places that the paths would intersect. And that's it. Thanks for watching, and I'll see you next time.